My name is Dmitry, and I'm a part of the Exactpro research team. At Exactpro, we build software to test software. Check out our website if you want to learn more about us. And remember to subscribe and hit the bell button to stay up to date with our new videos. We're continuing a series of videos for those preparing for the ISTQB exam. Today, we're going to talk about the first part of Chapter 4 called Test Techniques. If you missed the previous videos, you can find the links in the description below. Shall we begin? As we have mentioned before, testing is context-dependent and may have different levels of formality. Formal testing has very extensive documentation outlining test strategies, plans, reports, etc. It is usually well controlled and includes a description of entry and exit criteria. Informal testing, on the other hand, may have none of that, just some notes with tentative plans of what to test. Each project team chooses the approach and the level of formality depending on the system complexity, implied risks, required time, allocated budget, as well as on the traditions accepted within the company. Basically, what works for one project may not work for another. And now please bear with me, because I'm about to introduce a lot of definitions with the word test in each of them. One of the first steps that we do is performing test analysis. It is the process of looking for something to test using a set of inputs and outputs. This set is called a test case. If we determine that an item or a system event can be verified by a test case, it becomes a test condition. When identifying test conditions, we want to throw the net wide to identify as many of them as we can. After that, we will start being selective about which ones to develop and combine. In our first video, we explained that exhaustive testing isn't achievable. Therefore, we have to select a subset of all possible tests. In practice, this subset may be very small, and yet it has to have a high probability of finding most of the defects in a given system. We need a comprehensive guide for our selection, and test techniques are exactly that. Test conditions should be linked back to where they originated from. This is called traceability. It can be either horizontal, through all the test documentation for a given level, or vertical, from requirements to components. A test has to assess that the system does what it is supposed to do. It is the process of comparing the actual results to the expected ones. You can't just input some data. You also need to check what comes next. In order to know what the system should do, we need to have a source of information about the correct behavior of the system. This is called an oracle, or a test oracle, which has nothing to do with databases or the company that makes them. It comes from the ancient Greek oracle at Delphi, which has nothing to do with programming language. So this oracle served in the temple of Apollo, which has nothing to do with American lunar missions. Or was it the temple of Phoebe, which has nothing to do with the Friends sitcom? I digress, but I ask you to bear with me, and we're almost there. This oracle could supposedly predict the future with unerring accuracy, which is something that we need. We need an answer of what's going to happen or should happen. And sometimes, when the oracle doesn't deliver, we can still run a test based on plausibility or reasonableness. It is called a partial oracle, which is probably what they called a decapitated oracle in Delphi after her prophecy didn't come true. Just kidding. So let's start with an example of a full test oracle. We have a function that adds two numbers. If a is 2 and b is 2, then the end result is 4, which is what we expect. We know that these two inputs have a specific output. Let's consider an example of partial oracles. We don't know what's going to happen, but we expect the system not to crash, and we will be able to process even an erroneous input. The absence of a crash is a partial test oracle. Here's another one. We don't know how many shares will be traded during the day, but we know that the number of shares bought is equal to the number of shares sold. And here's one more. We have an intelligent virtual assistant. We can't predict the exact responses to the client's questions, but we can be sure that it's not going to use racial or sexist slurs. The next step is to take your test cases and execute them in a logical sequence. The document describing the order of test cases is called a test script. And there you have it, some important definitions to help you understand the material better. Now we are ready to talk about the main topic of this video, the test techniques. In the syllabus, test techniques are classified as black box, white box, or experience-based ones. Black box test techniques analyze the appropriate requirements, specifications, or business processes. These techniques are applicable to both functional and non-functional testing. Black box test techniques concentrate on inputs and outputs of the test object without referencing its internal structure. Test cases may be used to detect gaps between the requirements and their implementation, as well as deviations from them. White box test techniques analyze the architecture, the internal structure, or the code. They concentrate on what's inside the test object. Experience-based test techniques leverage the experience of developers, testers, and users to design and execute tests. This knowledge includes the expected use of the software, its environment, likely defects, and the distribution of those defects. These techniques are often combined with black box and white box test techniques. White box testing is based on the internal structure of the test object. When you have access to the code, tests can ensure that all internal components have been adequately exercised. It can be applied at all test levels, but the two code-related techniques discussed in this section are most commonly used at the component test level. Statement testing and coverage. A statement is the smallest indivisible unit of execution. This testing exercises the potential executable statements in the code. The objective is to ensure that all of such entities have been tried at least once. Coverage is measured as the number of statements executed by the tests divided by the total number of executable statements in the test object, normally expressed as a percentage. Decision testing and coverage. Decision testing exercises the code based on the outcomes. To do this, the test cases follow the control flows that occur from a decision point. Coverage is measured as the number of decision outcomes executed by the tests divided by the total number of decision outcomes in the test object, normally expressed as a percentage. When 100% statement coverage is achieved, it ensures that all executable statements in the code have been tested at least once, but it does not ensure that all decision logic has been tried. To achieve 100% decision coverage, you try all decision outcomes, which include the true and the false ones, even when there is no explicit false statement. For example, in the case of an if without an else. Achieving 100% decision coverage guarantees 100% statement coverage, but not vice versa. When applying experience-based techniques, we derive cases from the tester's skill and experience. These techniques can be helpful in identifying tests that are not easily detected by other more systematic techniques. Depending on the approach, these techniques may achieve varying degrees of effectiveness. Because of that, coverage can be difficult to assess or may not be measurable at all. Here are some commonly used experience-based techniques. Error guessing is a technique used to anticipate the occurrence of errors, defects, and failures based on the tester's knowledge working with similar functionalities, including how the application has worked in the past, what kind of errors tend to occur, and failures that have come up in other applications. In exploratory testing, informal tests are designed, executed, logged, and evaluated dynamically during test execution. The results are used to learn more about the system and to create tests for the areas that may need more attention. This kind of testing is most useful when there are few or inadequate specification, or there is a significant time pressure. Tests are usually not planned in advance. The team just launches the system and tries locating the bug clusters. Exploratory testing is sometimes session-based, constrained by a defined time box, with the tester using a charter containing objectives as a guide. Exploratory testing can complement other, more formal test techniques. In the checklist-based technique, testers design and execute tests to cover the conditions found in a checklist. For example, a login form list would probably contain the following steps: check the empty login and password fields, enter a wrong password or no password at all, and so on. As part of the analysis, testers create a new checklist or follow the existing one as is, or with modifications. Such lists can be built based on experience or knowledge about what is important for the end user, or an understanding of why and how the software fails. This concludes our today's video. If you liked it, give it a thumbs up. In the next one, we'll concentrate on the second part of Chapter 4 and talk about black box test techniques. We do have tons of interesting content for you on our channel, so feel free to subscribe and hit the bell button to be the first to see the new videos. Thank you for watching, and goodbye.